Hello and welcome to a low quality production of Snowball physics. It's going to be a rather slow production and going to have a look at the physics of projectiles. Let's talk about what that means. Well, let's have a look at a scenario. We have a physics student stood on top of a building 20 meters above the ground, and the physics student launches a projectile, in this case a snowball, at a velocity of 5 meters per second, and only launches the projectile horizontally. There's no movement up or down initially of the snowball. Obviously the snowball is going to accelerate downwards, but initially it's just thrown out of the hand horizontally at 5 meters per second. Now we'll call this part 1, and in this type of scenario we're going to look at the launch is only horizontal. There's only initial horizontal motion, there's no vertical motion initially. So how long does it take the snowball to land? How far does it travel? At what angle to the ground? Is it travelling when it lands or just before it lands? How fast is it going just before it lands? This is what we're going to have a look at. So the first question, question 1, calculate the time of flight. Normally the time of flight it's just an expression used for the amount of time something is moving through the air. It's the time just before the object lands from when it's launched, or from that initial moment when you're looking at its motion. Now you've used the Subat equations before, but here we've got to consider the horizontal motion and the vertical motion. So this time we need 2 Subat grids. We need 1 for the horizontal motion and we need 1 for the vertical motion. It's worth, although it takes a little amount of time to do this, it's worth spending the time drawing these grids out. Otherwise it's more likely that you will confuse the horizontal and vertical. So we've drawn our grids out there. Now what information can we add into those grids? If I ask a question on these videos, if you want them to be interactive, what you could do is pause them if I ask a question, give it some thought, and then replay and see what I've said. So what information can we add in the grids? Well, normally in a physics projectile question we assume that there's no air resistance. In fact, we assume that there are no forces except gravity. So if you hear the word projectile, a projectile question, normally that would involve something moving where it's only under the influence of gravity. Now obviously if you throw something on Earth, it's going to move through the air, and there will be some air resistance, and the faster it goes the greater the air resistance. But we're going to simplify projectile questions so that we're going to assume gravity is the only force and there is no air resistance. So if there's no air resistance acting horizontally, horizontally there'll be nothing to slow down or speed up the projectile, the snowball. So horizontally, the initial velocity to the right, so that's plus 5, and the final velocity, it's also plus 5. Although we say v is the final velocity, it depends what moment in time you're considering. The horizontal velocity will always remain at plus 5, so it's never going to change no matter what time you consider. The vertical velocity, well, initially there is no vertical velocity, it's only moving horizontally, no vertical motion just at the moment it leaves the hand. So the initial vertical velocity is 0. Now, just to come back to this idea of initial and final, when you're looking at a projectile question or an object moving under the influence of gravity, if there's no air resistance, we can say the vertical acceleration is minus 9.81, and we can say there are no horizontal forces if there's no air resistance, so A is 0. Now, this applies only if the object A can only be minus 9.81 if the only force is gravity, and the only force will be gravity once it's moving through the air. So we never really consider the case of the snowball in the hand and being launched out of the hand. It's just we start our time 0, if you like, the moment it's left the hand. And similarly, when we think about landing, we think about the moment just before it lands. So our final velocities will never be, we don't think of them as being 0 because something's hit the floor and remains stationary. We think about the moment just before it lands, while gravity is the only force on the object. If it hit the floor, there'd be an additional force. The equations we're going to look at only apply if we're only looking at the force of gravity. So we've got A minus 9.81.